Hi, my name is Darshini. I'm going to explain on the process description of my project. But first, our aim is to produce 4,000 kilograms of sugar per day from sugar beet, where when we convert it, we get 166.068 kilograms of sugar per hour. Okay, the initial raw material needed is 1,318 kilograms of sugar beet per hour, where the sugar beet will be flowed into this process as follows, like the mind map I did. Where firstly, it will flow through the slicer, where this sugar beet will be cut into thin and long slices, which is called corsets. Then the corsets will then proceed to the extractor, where the extractor will extract as much as juice possible from the corsets, where it will form a more liquid solution. The solution will then proceed to the heater, where the solution is heated. Then, after heating up, it will proceed to the clarifier, which consists of two stages, which is carbonation and liming. Carbonation and liming, which is in clarifier, functions to remove as much as solids possible from the solution. Then the solution will be flowed to the evaporator, where the evaporator's aim is to remove as much liquid from the solution to produce solid sugars. And the sugar produced from our process will get an amount of 166.068 kilograms of sugar per hour. Thank you.
Hello, my name is Nor Azra Afifa. I'll be explaining about the process selection route for my group. First, we decided to use slicer for our first process. Then, we use extractor, and then straight to the clarifier process, which include the carbonation and liming. And lastly, we use evaporator as our last process.
Okay, the assumption made for this project, there is two, which is first, slicer has an 100% efficiency, and second, clarifier has an 100% efficiency.
So this is our PFD diagram, including all the process and also the temperature for each of the equipment. First, we go to the slicer. We use 1,318 kg of sugar beet as the input for the slicer, and the output is just the same as the input. Next, we go to the extractor. The input of the extractor is the output from the slicer, and we add 50 kg water into the extractor, and there is two products from the extractor, which is stream 4 and stream 3. For the stream 4, the total flow rate is 988.688 kg per hour, and the composition for the stream 4 is water, solid, sugar, and the impurities. For stream 3, the total flow rate is 379.312 kg per hour, and the composition is just the same, which is water, solid, sugar, and impurities. Next, we go to the heater process. For the heater process, the input for the heater is coming out from the extractor, and we use temperature 55 degrees Celsius, and then the output from the heater is just the same as the input, which is 988.688 kg per hour, and also the composition is just the same. For clarifier process, which include the carbonation and liming process, the input for carbonation is the output from the heater, and we add 0.326 kg per hour of carbon dioxide, and the product is stream 6, which the total flow rate is 989.014 kg per hour, and the composition is water, solid, sugar, and impurities. For liming, we add calcium hydroxide, and then there is two output, which is stream 7 and stream 8. The total flow rate for stream 8 is 957.347 kg per hour, and the composition is water, sugar, and impurities. For stream 7, the total flow rate is 31.67 kg per hour, and the composition is sugar and calcium carbonate. For the evaporator, the input for the evaporator is output from the second heater. Actually, in the second heater, we heat the solution with temperature of 80 degrees Celsius, and then the output is the water vapor, which is 702.88 kg of water, which temperature is 100 degrees Celsius, and then there is steam in and steam out. For steam in, the temperature is 130 degrees Celsius, and steam out is 100 degrees Celsius. For the output from the evaporator is 254.46 kg per hour, and the composition is water, sugar, and impurities.
Hi, so my name is Nuridaya binti Muhammad Zahari. I am from the group di Malindo, and then for today I will explain about the costing and the cash flow for our company, which is the Malindo. Okay, we have two types of cost, which is total capital cost and operating cost. For the total capital cost, we have 7 parts, which is estimating ISBL using the length factor, which is 3.86, OSBL, which is 40% of ISBL, design and engineering, which is 20% of ISBL and OSBL, contingency 10% of ISBL and OSBL, total fixed cost, which is sum of the ISBL, OSBL, design and engineering, and contingency. And then we have estimating working capital, and then total investment required. So total investment required for our company, we got 1 million something. And then we have operating cost, which is two types, variable cost and fixed cost. For variable cost, we have raw materials and utilities. Under raw materials, we have sugar beet, carbon dioxide, and calcium oxide. As we use the process clarifier, which is consists of carbonation and liming. For utilities, we got water, boiler, and electricity. But the value of electricity is null because we didn't learn about the energy balance. And then for our cash flow, we are able to determine the value of our cash flow from year 1 until year 20th. From year 1 until the second year, we got negative value as we are very new in the business entrepreneurship. For our cash flow diagram, from the second year to from first year to second year, it is slightly dropped. As you can see beside it, it is negative value, and from the third year until 20 years is extremely increasing. So
my name is Arif Arhan, and I will explain about the conclusion and the recommendation for the future works. And this is the conclusion summary of the project. From the project that we have managed to complete, we were able to gain information using social network and journal from library. And then we were also able to achieve the task given, which to produce 4,000 kg per day sugar per day. And this is the recommendation for future project. This is the several ways in order to improve the final outcome of the sugar manufacturing. Firstly, we should facilitate the investment aimed at making sugar mills more efficient. And by purchasing more improvised equipment with a higher efficiency, it can help to increase the quantity of the sugar produced in a batch. And besides, we should also use high quality sugar beet, which contain higher amount of sugar, and furthermore, the biggest release at the extractor process can be used to fuel the high pressure steam boilers. In this way, it will reduce the electricity cost and reduce the production cost.